Hello everyone, I am Sander Vandendriessche working for Inagro, and during this presentation I will give you some insights in the fertilization value of digestate. Because in order to make the most profit out of your biogas installation, it is also quite important to have a good valorization of the digestate, which would otherwise create an extra cost. First of all, let me start by introducing Inagro, since I think most of you do not know our organization yet. Inagro is a practice-oriented research and advice center in Belgium specialized in agriculture and horticulture, and we see ourselves as the link between the farmer and the more academic research. On the one hand, we translate academic research to practical advices, but on the other hand, we bring back challenges from practice and translate them into new research questions. So we are really in between farmers and universities. We focus on technologies that have already a TRL level of 6 and higher, and we work together with a lot of different stakeholders like other practice centers, universities, companies, and so on. But our main target group is farmers to inform them as much as possible. I mentioned that we are a research and advice center in agriculture and horticulture, and with this I mean we are specialized in all aspects of agriculture, like you can see on this picture. We do research in animal husbandry, arable farming, greenhouses, organic agriculture, even mushroom growing, insect farming, aquaculture, and so on and so on. I work in the Department of Energy and Circular Economy, where I am mainly working on different projects related to nutrient recovery and farm-scale anaerobic digestion. At Inagro, we have our own farm-scale biogas installation built for the purpose of research and demonstration. Because of our broad experience with nutrient recovery and anaerobic digestion, we were asked to give a presentation on the value of digestate. This is also something that is an important part of the Horizon 2020 project Nutri2Cycle. The Nutri2Cycle project is coordinated by Ghent University and has the main goal to close nutrient loops. And to achieve this, it uses an integrated approach to enable the transition from the current suboptimal nutrient household in European agriculture to a more sustainable agriculture. And this is necessary because nutrient use efficiency could be significantly improved by integrating on-farm techniques and systems. On the one hand, there is animal husbandry, which leads to a lot of nutrients, but on the other hand, there is crop production, which needs the nutrients. And Nutri2Cycle really tries to reconnect these two main pillars by creating a third pillar, namely agro-processing. And this is done in the project by benchmarking existing NPC flows and to propose and test innovative technologies at local level. And these technologies are being validated via lighthouse demonstrations. The main goal of this approach is then to elaborate strategic scenarios to identify the effect of these innovations at the European scale, and also by providing life cycle analysis, cost-benefit analysis, social LCAs, and so on. And one example of agro-processing that is being investigated within the Nutri2Cycle project is farm-scale anaerobic digestion, which is a technology that is able to create energy from animal manure and/or crop residues. And next to the energy production, anaerobic digestion also creates digestate. And within the Nutri2Cycle project, we also do research on the use of this digestate as a fertilizer. And today I will share some thoughts of this with you. So during this presentation, I will focus on four main parts. I will start with a short introduction of what farm-scale anaerobic digestion is. I guess most of you already know the process, so I will go quickly through that. Next, I will present the impact of anaerobic digestion on the availability of nutrients. I will give you some insights on the differences of raw manure on the one side and digestate on the other side. And then I will short talk about some further processing possibilities of digestate. You can use raw digestate as a fertilizer, but it is also possible to further process this into more valuable end products. And I will finish the presentation with giving some insights and points of attention when using digestate as a fertilizer. I will try to give my presentation from a practical point of view. On this picture, you can see the anaerobic digestion installation at Inagro. This is a typical continuously stirred tank reactor operated at mesophilic temperatures. So basically, the principle is that biomass is fed into the reactor, and the biomass will subsequently be transformed into biogas because of a consortium of different types of microorganisms. The incoming biomass can be liquid or solid. Liquid biomass is, for example, cattle slurry, and solid biomass can be crop residues or the solid fraction of manure after solid-liquid separation. The installation at Inagro is mainly fed with the solid fraction of pig manure and crop residues. The produced biogas consists mainly of methane, which is the energy-rich component of biogas. The share of methane is about 50 to 75%, and the rest of the biogas is mainly carbon dioxide, but biogas contains also some sulfur and water vapor. And it is very important to remove these two elements as much as possible to prevent any damage. And then the desulfurized and dewatered biogas is transported to a combined heat and power installation, where there is energy generation in the form of heat and electricity. A part of this renewable energy is necessary for the biogas installation itself, and in general this is about 15%, but the rest of the energy can be used on farm as energy source. So this brings me now to what is farm-scale anaerobic digestion. There is no strict definition on what it exactly means, but there is a general consensus that we, at least in Belgium, talk about farm-scale when proprietary biomass is used to produce renewable energy that is being used on farm. So the proprietary character is really important. We talk about quantities of max 5,000 tons biomass per year. And in general, 1 cubic meter of biogas has the value of 1.5 kilowatt hours of electricity and 2 kilowatt hours of heat. Of course, these are average values, which will in some cases be higher and in other cases be lower. The digested biomass is called the digestate, and during the next slides I will focus on this digestate, what are its properties and how can you valorize it as good as possible. Mostly the digestate is being stored in an external storage tank, and compared to the input material, which is in the case of farm-scale anaerobic digestion mostly manure, digestate contains less dry matter and organic matter. But important to mention here is that complex organic compounds like lignin are more difficult to break down, and as a result the digestate is still containing some organic matter that can be useful for the soil. Another important feature of the digestate is that a part of the organic bound nitrogen is converted into mineralized nitrogen, so it is more available for crops. The other nutrients like potassium and phosphorus stay more or less the same. You can see this also in this table. The upper table indicates the differences between cattle slurry before digestion and the resulting digestate after the ID process of this cattle slurry. And you can clearly see that indeed the dry matter and organic matter is decreased with about 30%, while the amount of total nutrients remains more or less the same. But if we look at the mineralized nitrogen, we notice that there is a quite big difference. The cattle slurry has an average mineralized nitrogen content of 2.07 kg per ton, while this is 2.46 kg per ton for the digestate. If we look at the table below, we notice that the organic material is, we notice that organic material that is quite easy to break down is less in the digestate than in the cattle slurry. This is the case for cellulose and hemicellulose. But if we look at organic material that is more difficult to break down, like for example lignin, we notice that there is relatively seen more lignin in the digestate than in the cattle slurry. Of course, there is no extra lignin produced because of the AD process, but since the dry matter content is decreasing and the amount of lignin is more or less the same, there is relatively seen more lignin in the digestate, which is also a source of organic matter. The numbers I showed on the previous slides are average values for a cattle farm, but it is very important to know that the composition of the digestate is strongly varying. It is amongst others dependent on the input material, and there will be a big difference between farm scale AD, where there is mainly monodigestion of manure, versus big scale AD, where there is mostly co-digestion of manure and crop residues. The composition of the digestate will also depend on the AD process itself. For example, the temperature has an influence. It will be different if it is operated at mesophilic or thermophilic temperatures. And of course, there will also be some seasonal differences, which also has an influence on the input material, since not all biomass is available throughout the whole year. So therefore, the most important rule when using digestate as a fertilizer is to know your product. We always advise to take enough analysis of the product to exactly know what's in it, especially when you use digestate that you did not produce yourself. Digestate could be a great fertilizer because of the higher amount of mineralized nitrogen, but of course you exactly need to know what's in it. Next to using digestate directly as a fertilizer, there are also some further processing steps possible. The first step is mostly solid-liquid separation because of, for example, a centrifuge. Then the solid fraction can be further dried, and the liquid fraction can be further processed to produce different types of digestate products. I will quickly guide you through the differences in these products. So, the raw digestate contains in general less than 15% dry matter, and the amount of mineralized nitrogen is higher. But other nutrients like phosphorus and potassium will remain more or less unchanged. There will be also a decrease in organic matter. If we separate this digestate in a solid and a liquid fraction, then we will notice that most of the dry matter and organic matter will be in the solid fraction, and also the solid fraction will contain most of the phosphorus. The liquid fraction, on the other hand, will contain most of the nitrogen and potassium. The share of nutrients in the solid and liquid fraction, as well as the share of dry matter and organic matter, is of course dependent on what separation technique was being used. The solid fraction can then further be dried to produce a product that contains even a higher dry matter content. This is a product that can, for example, be used as bedding material, of course, when there are no contaminants. So this is the dried digestate. The liquid fraction can be further processed on several ways. There is the biological manure processing to produce an effluent that contains almost no dry matter, no nitrogen, and no phosphorus. The effluent will only contain some potassium. Next to this, an alternative is stripping scrubbing to produce ammonium salts. Depending on what acid is being used in the process, you can produce, for example, ammonium sulfate or ammonium nitrate. And in general, these products are good nitrogen fertilizers. And another last technique is membrane filtration to produce mineral concentrate, and that's a product that is getting close to the same properties as mineral fertilizers. So I went quite quickly through this table, but the most important message here is that there are further processing steps possible which can upgrade the value of the digestate. Of course, it needs extra investments. In some cases, this will be profitable, in other cases, this will be more difficult. When we now have a look at how to apply the raw digestate on the field, important to keep in mind is that the amount of mineralized nitrogen is quite high. So while the ratio of mineralized nitrogen on organic nitrogen is only about 50% for manure, this ratio will increase up to 66% for digestate. So the nitrogen is much more available, which means that the timing of application should be considered carefully. Also important to know is that because of AD, the amount of organic matter decreases, but the digestate still contains stable organic matter that can be used by the soil. It has already been proven that digestate is not harmful for soil life. In general, when applying digestate, you need to take into account 4 rules. Use the right timing, keeping in mind the nitrogen availability. Know the composition of the digestate, since it can vary quite a lot amongst the different types of installations. Use the right dose that is necessary for your soil and crop based on an analysis of the digestate, and of course use the right application method. Regarding the application method, it is important to know that the pH of digestate is somewhat higher than the pH of manure, so there is more risk of ammonia volatilization. Therefore, we always advise to inject digestate directly in the soil or to use a drag hose system. Injection is the best practice to prevent ammonia emissions, but also with drag hoses, most of the ammonia emissions will already be prevented. And of course, when using digestate as a fertilizer, it is also of importance to take into account the legislation. In Belgium, the digestate is seen as animal manure as long as there is 1 droplet of manure going into the digester, resulting in a limited use. This is up to date, also the case for the further processed products. So the local legislation is of course an important factor when applying digestate. At Inagro, we have a lot of experience of performing field trials to know the added value of recycling derived fertilizers in terms of agronomic and environmental value. And with recycling derived fertilizer, we mean products that are derived originally from manure, like for example digestate, ammonium nitrate, ammonium sulfate, liquid fraction of manure, and so on. For the moment, within the European projects Renew to Farm and Nutri to Cycle, we have a 3-year field trial in which we test 7 of these recycling-derived fertilizers in 4 different concentrations. And the goal of this field trial is to derive the nitrogen fertilizer replacement value of each of these alternative fertilizers. In 2019, we used maize as crop in this field trial, in 2020 spinach followed by maize, and in 2021 early potatoes. The full results are not published yet, but I can already say that in general the recycling derived fertilizers did not perform bad compared to the mineral fertilizers. If you should be interested in this whole research, this will normally be published in 2022, so next year. We now know something about the properties of digestate, but for what crops can we use that digestate now? Well, in general, digestate is a great product for crops with a long growing season followed by a cover crop, or it is also used a lot on grassland. As a conclusion, we can say that digestate could be a great fertilizer for example, grassland, but there are, of course, some points of attention. First of all, the timing of application is really important. Also, the application method is important to prevent ammonia emissions, and here injection is in fact the best option. Also, you need to take into account some legislative aspects, but the most important, in my opinion, is to know your product. Just take a lot of analysis of the product you use on the field then there could be some variation on it. But in general, if you can have a stable product, then the value of digestate could be very high in terms of fertilization, and it's a great product to use on, for example, grassland. So this was my presentation. Of course, when you should have any more questions or suggestions, please feel free to send me an email or to ask me directly. Thank you.